I hope the screen is not too small, Lungile. All right. I'll take.
If you're able to, yeah, yes,
All right. Awesome.
that looks good.
Okay,
Okay.
good. All right. So let's say that my research question is as follows. So let's put this as research question. So again, I cannot emphasize enough. Don't just take a data set and just jump into any software. It doesn't matter. To start analyzing, you have to sit down and ideate with the data, right? What are you, remember this, let's go back to this screen. Yes. So all of us, this is why we went through these screens yesterday. So that will set the baseline or the foundation for today. So yesterday we learned about all those variables. So your job first and foremost is to map all of those variables that we discussed here to your data set, right? There's no point just drawing the DAG. By the way, we call this a DAG. DAG means directed cyclic graph, right? There's no point just drawing DAGs. The DAGs should have meaningful relevance to your data set. Without your mapping of them to your data set, it's useless. So first step number one is not to download data and start looking at it. No, it's not to import data. No, no, no. Step number one is just to think, right? You're all philosophers here. So think about what are you trying to achieve? What these variables mean? What's my exposure? What's my outcome? How am I going to measure it? Are they confounders? What are they? Right. So let's do that. So here, let's say that my research question is the association between, let's say, periodontal disease and diabetes. So that's my research question. And ideally, this question shouldn't be a question I just plucked out of the random wheel of epidemiology. There should be some plausible reason, right? If you're familiar with Hill's criteria, Hill's criteria forms the basis upon which we think or frame issues in epidemiology, right? It talks about things like consistency and coherence and etiologic plausibility. So here we are saying, well, we think it's etiologically plausible, or it is plausible that if you have gum disease, that could be associated with diabetes. Why? Well, because periodontal disease is an inflammation, right? And that might have something to do with, insulin resistance. And by that pathway, we could have diabetes, right? At least we have some theory. If you're going to do research, there has to be some underlying theory before you start. There has to be some mechanism you are thinking of. Something must have driven you to explore a particular question, right? Research questions are driven by our own biases. So every research question, by definition, is subjective because they come from our biases, they come from our fears or interests or things we just want to explore. So there's no research question that is objective. However, what we ask is that the methods which we use to explore them must be objective. So the research questions themselves are subjective, obviously, but the mechanisms which we explore them have to be objective so that they are reproducible. All right, so that's our research question. So here, we can see that our exposure is, what's the exposure? So let me get your input from to make sure that we all learn from yesterday. So in this research question, what is exposure? I'm looking at people able to participate.
Periodontal disease,
Okay, already. Any question that is unanswered will have to be answered by,
diabetes.
and any question that sorry, any question that's not answered will have to be answered by you, Lungile. I heard somebody say diabetes. Can that person explain why they think it's diabetes?
Micah, you can unmute and speak if you'd like to.
Okay, so I've tried to provide very short descriptions of what they mean. Exposure is where we start. Outcome is where we end. So think of it as a journey. Start from point A, we end at point B. In our pictures yesterday, we start from the tank here, and we end all the way in the basin here. Where we start is called the exposure. Where we end is called the outcome. All right. So based on that short description, I'll ask again, what is the exposure? And I hope to get a unanimous answer now.
I'll read the last response. Diabetes is the exposure because our outcome of interest is periodontal disease.
Okay. Generally, right, the way we frame the sentence tells you which comes first. Remember, I will say exposure is where we start, and the outcome is where we end. So if you don't know what it is, just look at the sentence. And this is your job too when you're framing the language. We frame in such a way that the exposure is the first thing that appears in the sentence, and the outcome is the last thing that appears. So here, you can see that periodontal disease appears first. So that means that it is exposure. And diabetes appears last, which means it's the outcome. It would be very bizarre for anyone to write the association between diabetes and periodontal disease when they meant the reverse. So please, when you're writing, these are some of the more of the traditions in scientific writing. Make sure that exposure comes first and the outcome comes last. So here, the exposure where we start is periodontal disease. And the outcome here is diabetes. Now, in another study, right, it could be the other way around. Another person might be interested in is an association between being diagnosed with diabetes and developing periodontal disease. That's also a valid question. But in this particular research question, that's not what we're looking at. We're looking at how does a diagnosis of periodontal disease, how is that associated with diabetes, right? All right. Now, so exposure, periodontal disease, outcome, diabetes. When we think of the exposure and outcome, it's not sufficient for us to just name them. We also have to worry about measurement, right? For any indicator, there could be many ways that it could be measured. It could be measured by self-report. It could be measured in the lab. It could be measured by a doctor healthcare examination, right? By a healthcare provider. If we have a choice between self-reports and either of lab or exam, which do you think will be better for us to use? Should we go ahead and use self-report or should we use lab/exam? And why?
I think it's better to use lab
Okay. Why?
because the lab will confirm it. Self-report might still be doubting,
Okay.
but lab stroke examination will confirm whether the periodontal disease occurs and the diabetes.
Okay. Thank you very much. Let me just put this in short term before I cause some tooth loss here. So let's just call it gum disease. All right. So periodontal disease means gum disease. All right. So you're absolutely right. Right. So now can you rephrase it a little bit more scientifically? Yesterday we talked about 3 types of biases, right? We talked about let's go back to our slides from yesterday. We talked about confounding bias, measurement bias, and selection bias. What is the issue here with the distinction between self-reports versus lab? What is it? What's the prime issue? Which of those biases are we trying to mitigate?
Measurement bias.
Okay, and how could it manifest in this case? Because remember, we're talking about gum disease, right? The guy says, I have gum disease or I don't have gum disease. What about measurement bias comes into play here in this issue now? Do we have any dentists? No, are there any dentists in the house? None. But regardless, even if you're not a dentist, the idea is if a person says they don't have gum disease, can that report always be true? Or is it possible that it may be untrue?
Yes, both might be
It
true
can be
or
both, sir.
Maybe subjective.
Yeah, subjective, right? If
Yes,
I
it is
Yes,
subjective.
it's subjective.
if I ask people, the people who have gum disease here to raise their hands, I'm not sure anyone will raise their hand. But if I were to have a dentist come and examine everybody here, maybe all of us have some degree of gum disease. So we don't even know that you have it, right? So that's the problem with self-reports, right? And so the issue of misclassification comes into play, right? Because here we're saying, individuals may misclassify their gum disease, right? Now, there are two forms of misclassification. One is okay, the other is bad, right? One is differential misclassification. The other is non-differential. Which can we live with and which is absolutely bad? What do you think? So in other words, here we're saying that, right? Remember, the classification is between having periodontal disease and not having periodontal disease. Those are the two we're talking about, not having, right? So misclassification means that what we're saying is that some people who truly have periodontal disease may report that they don't have. And some people who don't have may report that they have, right? So, those who report are supposed to say they have, and those who don't have are supposed to say they don't have. But misclassification means that we can sometimes switch those two groups. So what we're saying is that it could be differential or non-differential. From just the English language, from just the lay meaning of that word, what does it mean? Which one sounds to be worse? Just from looking at the terms.
Non-differential cannot be classified. Why differential can be classified?
So if it's differential, if it's non-differential, we're saying that we're having both sides are equally screwed. Remember, we're talking about on one hand, we have those who have periodontitis, on the other hand, those who do not have it. So we're saying that both sides are equally screwed. And so that means that, 50-50, right, evens out. So we don't have much damage there. In differential, we're saying that, well, it leans heavily to one side, right? Because it's possible that those who have periodontal disease, may likely misclassify themselves as not having. But those who do not have it truly are likely to report that they don't have it. So in that case, you end up with a differential misclassification. In some future classes, we'll dive a bit more into the scientific implications of differential misclassification. But for now, let's just keep it at a high level and say that the reason we prefer lab or objective measures is to avoid things like this. We want to avoid misclassification. So we have our exposure, we have our outcome. Now let's worry about confounders, right? Sorry, let me find a way of hiding this thing. It's in my way. I'm sure you guys can't see it, but the Zoom display covers like half of my screen. Let me find a way of hiding this. Did it already. All right, let's now talk about confounders. Who can remind us of what confounders are? Because remember, we have to map out those variables to what we showed yesterday, right? So what's a confounder? Let's look at the picture directly here. Yeah, Micah, your hand is up.
Okay, thank you so much, Prof. I think a confounder is a variable which actually can affect both the, let me say, explanatory. For this case, we can say exposure and the outcome. So they do affect the two variables at the same time. So I would say that.
Okay, very good. So put another way, there's another person that raised their hands. Maybe somebody wants to add a clarifying point or to completely reject your argument. Let's see, who is that? Chinedu.
Thank you, Prof. Co-founder, from what you said yesterday, co-founder are those things that can lead from exposure to outcome without passing the causal pathway.
Excellent. You just added the third element, which was missing from Micah's explanation. So confounder is independently associated with the exposure and independently associated with the outcome and does not lie on the causal pathway. You see, that's the distinction between the confounder and the mediator. The mediator too has ties to the exposure and also has ties to the outcome. But in contrast, the mediator lies on the causal pathway, right? So those are the three criteria for a variable to be called a confounder. And by the way, it's not a co-founder. Co-founder is a business term. It has to be associated with exposure, it has to be associated with the outcome, and it must not lie on the causal pathway. All right, now let's go back to our ideation part. The exposure here is periodontal disease. The outcome is diabetes. What are some of the variables that you can think of that are associated with the exposure, which is gum disease? I should really stop calling this periodontal disease so that we can all understand. Gum disease, and it's also associated with diabetes and does not lie on the causal pathway. Lie on the causal pathway means that we are saying that it is not that you have gum disease and then you develop the condition and then you develop diabetes. So that's not what we're saying, right? So for example, X could be inflammation, some inflammatory biomarker, right? So for example, if you have C-reactive protein, that's a marker of inflammation or just, some action in the body, right? You could argue that you have gum disease, then you have elevated levels of C-reactive protein, which may or may not contribute to diabetes. So in that case, if that is true, you could argue that this is on the causal pathway. So you should not adjust for it. Now, having explained what the confounder, what are some of the variables that we could identify as a confounder in our study here? Are there hands up? I can't see any hands if there are.
There are no hands.
Okay,
Someone typed age.
Sorry?
Someone said age.
Excellent. So age.
Gender.
Can you explain why age is a confounder? And by the way, what's the most important tool to detect for confounders? Who knows this answer? What is the most important tool you can use to identify confounders? No answers? How come we're very so shy today?
Modeling, lab investigation.
No, no to both.
DAG.
No,
Regression.
no,
Previous studies.
no,
History.
no. All right. One more attempt.
Causal diagrams.
No. All right. The answer is your brain. Common sense. Okay. In technical language, you call that subject matter expertise. or domain expertise. That's just a fancy word to say your brain and common sense. You are the researcher, you know the context. You should be able to say that, yeah, I think in this relationship, forget about what other studies did. Because the fact that something is a confounder in a previous study does not mean that it's a confounder in your own study, right? It might be a completely different population. So don't just go grab confounders from another study and say, well, those people say it's a confounder there, so it has to be confounder here. That makes no sense because you have completely ignored context, right? So it is not that, it's not previous studies, it's your common sense, and your expertise in that domain, right? That is the most important. That is why before you jump into any research, you need to sit down with your notepad or whatever it is you're ideating with and think. You got to think, because research is about thinking, right? All right, so who can explain to us why age is a confounder in this case? Based on the 3 criteria for confounders. Here's how I expect you to frame it. People who are, okay, I see a hand up. Okay, good. Olua, Belumi.
Okay, thank you so much, sir. I think maybe it's because a person can have periodontal disease. A person of any age can have periodontal disease, or they can also have diabetes. It's not related in the sense that you must have periodontal disease. I mean, you must have diabetes before you have periodontal disease, or you must have yes, it's not related in the sense that the two are linked, but it can happen to either. So it's independent. It can be related independently to either of
Okay.
the 2 factors.
All right, thanks. Now you've done very well in explaining the part that they are independent, but you've not gone to great length to tell us the relationship, right? When you explain the relationship, we want to hear the magnitude of the relationship. You don't have to give us numbers, and also the direction. For example, you could say older people are more likely to blank, or younger people are more likely to blank, and also older people or younger people are more likely to blank. So in this way, I'm arguing that age is independently associated with gum disease and independently associated with diabetes. So that's how I want us to frame it. All right, I see another hand up.
Desalegn.
Okay.
I think age by itself is a risk factor for diabetes mellitus.
Okay.
You know that there is diabetes type 1 and type 2. Sometimes it is age related. So it may be an independent risk factor for the diabetes mellitus.
Okay, thank you. Now, in general, when we talk about in epidemiology class, we always want to be very precise in what we're saying. So it's not enough to say it's age is related. We want you to tell us the direction of that relationship as well. Okay, who else? I saw your hand raised up briefly. Yes, Ifeoma Chuku.
Okay. Age being a confounder for periodontal disease and diabetes. Like as someone ages, the oral hygiene gets low. For example, when you eat food and when you have foods that when you eat foods, for example, you have a calcified food particles in your teeth, like the toothbrush cannot remove, and it stays there for a longer time, it can affect your oral hygiene. You can start having bleeding gum. From bleeding gum, it will now proceed to periodontal diseases. That's why the reason why I said age can also perform periodontal diseases. For diabetes, depending on the type of food you eat when you are younger, as you age, you will see that's when you will not get the repercussion of those things, those diets you have been eating when you were younger. As you age, you will see them coming down and start affecting you because you have been living that kind of lifestyle when you're younger. So it can also, because of your age, you will notice that it can also perform the individual having diabetes. You see, majority of the people that have diabetes is at the later age in life. So because of the accumulation of the things they ate when they were younger. So
Okay.
that's why it's advised that you should mind your lifestyle, the way you choose your diet, so that it will not affect you at later in life. So that's what I want to.
Thanks for the lifestyle counseling too. Thank you. I saw somebody else's hands. Is it Bola?
Okay, thank you, sir. From my opinion, I think confounder, as you age, the cells of the body gets to decrease. I mean, gets to be weakened with time. So, whatever you eat inside the body, despite the fact that the diabetes can be 1 or 2, it can affect people that are young too. But when you age, in the way the immune system fights is reduced. So it can be the confounder for age. Thank you, sir.
All right, thanks. Now, I want somebody to very concisely, you don't have to give the underlying mechanism of action, but very concisely now tell us why age is, and all of you are correct, by the way, but now we want brevity. Taiwo, your hand is up.
Hello, thank you very much, Prof.
Good afternoon, Prof.
Hello.
Yeah, age is a risk factor for the commonest form of diabetes, which is type 2 diabetes. As one ages, the tendency to develop diabetes, type 2 diabetes also increases. Similarly, as one ages, in the prevalence of gum disease also increases.
Okay.
So both of them are related to gum disease.
Okay, excellent. But what of a third criterion? Remember, you have eloquently answered.
The other thing here, sir, is that the pathway between diabetes and gum disease, age does not really come into play here. There are some mechanisms between diabetes and gum disease.
Excellent. So just so we're all very clear, what is it that you cannot say that does not even make any sense? If we're talking about age on the causal pathway, what can't you say that that would hold true here for us to say that, yeah, age does not lie on the causal pathway? So we're saying that it's not the case that you have gum disease, and then what? Who can map out that thought process for us so that we can all understand what we mean when we say age does not lie on the causal pathway? Yes, Emmanuel.
I think you will say it's not because you have gum disease and you are old or you are young. It could happen to either the young or the old, but we could say that it has a positive association with gum disease.
Excellent. So as we can't say that, oh, you develop gum disease. So we can't say this. We can't say, oh, this guy developed gum disease. Then he got older. That made him get older. And then he got diabetes, right? That makes no sense whatsoever. Age does not lie on the causal pathway because it does not lie on the causal pathway here. So in this case, definitely age is a confounder. All right, what are the confounders? Now we can just list the other ones, right? So we'll talk about age. What other confounders do we have here of that relationship? Now that we fully understand what confounders are. Yes, Chuku. Ifeoma.
The diet and lifestyle can also be.
Okay. So diet and lifestyle. Okay. What else could be a confounder? How come you guys are not thinking of the most common things? Most common demographic variables. Yes, Bola.
Sex.
Exactly. That's the first thing you should be thinking about. Age.
Hereditary also.
Once you
Sex.
mentioned age.
Sex and heredity, yeah.
Yeah. All right. What else? What other demographic variables? Again, common things occur commonly, right? Don't think of some far-fetched things when the most immediate or most apparent things have not been listed. Okay, what other things that will be associated with gum disease? Think of socioeconomic factors, right? How about yes, Bola?
Maybe education.
Yeah. So how will
Hereditary.
how could education be a confounder?
Well, if there is no knowledge or awareness of what the person is supposed to eat or the location where the person is, and they eat just anything, it can affect the teeth, the gum rather.
Exactly.
As well as expose persons to diabetes.
Exactly. So these are important confounders, right? So now we have to list all of these things out, right? What happens when we have an important confounder, but we forgot it? We did not include in our analysis. What do we call that? You have a very important confounder which you did not account for. You did not list it down, and hence you did not include in the analysis. What's that problem you have on your hands now? I saw your hand raised. Yeah, Emmanuel, worry.
We say that's confounding bias.
Confounding bias, yeah. So you have unmeasured confounding, right? So that's a specific term we're looking for. Unmeasured confounding, because you did not measure it. So here in this case, we have where's my text now? Unmeasured confounding. Right. Which is different from, another problem which we call residual confounding. What's the difference between these two terms? Unmeasured confounding. So in unmeasured confounding, we did not do what? Versus in residual confounding, we did not do what? Who wants to take the first one? So in unmeasured confounding, what did we not do? Yes, Taiwo.
Thank you very much, Prof. In unmeasured confounding, it means that we forgot to account for that confounding variable.
Exactly. So,
but residual confounding, for residual confounding, it means that no matter what we do, there are some confounding variables that we may not completely account for.
Can you give me an example? So the first one is very clear, right? Unmeasured, you said, oh, in this list we are writing now, we did not list that variable. And so in our analysis, we did not include it in our regression, right? So that's very clear. We have unmeasured confounding. We did not measure it. So it could be that we didn't add it in our questionnaire yesterday, or we added it in the questionnaire, but we didn't add it on our list here, or we added it on the list here, but it's for whatever reason, did not make its way to the analysis. So it's unmeasured. So, but what example, so that we are all on the same page, can we give to understand residual confounding?
Well, I think residual confounding, they are confounding variables that we may not even know about. We may have the knowledge of.
Okay. But if we don't have a knowledge of it, that means we didn't measure it, right?
Yes, we didn't measure it because we never knew that it will affect our outcome.
Okay, so where will you place that? Will that be unmeasured or would that be residual then?
That is residual confounding.
No, but you said we did not measure it at all. We did not know we did not know it existed, right?
We didn't measure because we didn't know that it existed. But
Okay.
for the unmeasured confounding, we are aware that it existed, but we forgot to measure it.
Okay. So here is the thing, right? Whether you are aware, as far as you not measure it, it doesn't matter whether you are aware of it or you're not aware of it. We don't really care. As far as you did not measure it, it's still unmeasured confounding. Does that make sense?
Okay, yes, sir.
Alrighty. So now we're still left with the problem of residual. Residue. What does the word residue mean? Yeah, Samuel, your hand is up.
Okay, thank you, Prof. The residual means that we accounted for it in our analysis, but due to the limitations, probably on the limitations of the technique we use, we will not be able to 100% eliminate the effect of that confounder. So the remnant effect of that confounder is the residual, while the unaccounted confounding were the ones that we were unaware of, or whether we were unaware, but we did not measure it.
All right. All right. You've heard of this expression, half bread is better than none. What does that expression mean?
It means it means it's better we take it into account, the confounder into account, even though we will not be able to totally control for it.
No, I mean
better
literally.
than not accounting for it.
I mean literally.
Okay, literally.
Yeah.
Yeah, it means it's better to have at least some of the bread than to go hungry entirely.
So you had the bread, but are you fully satisfied with half bread? You ate the half.
One
half
is not
bread.
Okay. One
But
is not
still,
fully satisfied.
Yes, you're
or
not fully
it's
satisfied.
better than going hungry.
Okay. Now let's apply that principle, right, to age. So here we have age here on our age has appeared on our list here, right? So at face value, we say, oh yeah, we accounted for age. But imagine that this is how we accounted for age. We divide age into two big groups, 50 plus, or let's say less than 50 versus 50 plus, right? So, in theory, if somebody will ask you, have you controlled for age? You would say, of course I did. I included age in my list. It also appeared in my model. But look at those huge chunks, right? That's a huge chunk. Within the groups of less than 50 and the group of 50 plus, do you think those are homogeneous groups or are they very heterogeneous groups? What do you think?
I think it's very heterogeneous.
Exactly. So that means that even within the less than 50 group, what action is still going on there? That begins with the C word. Remember, confounding says that there are groups are different and that is affecting the results, right? So that means that even though we have we've provided half bread, right? But that doesn't take care of a problem because even within those two huge slices, you still have a lot of confounding going on within those two groups. So you have tried, there's been an attempt to adjust for something, but it's still not sufficient, all right? And this is why we always talk about in epidemiology, the trade-offs between precision and validity. This is always a problem that you as an investigator must always be aware of. You must be aware that the more you give attention to precision, that means that you are downgrading validity, right? As precision goes up, validity goes down. Because here, precision means that, remember, precision means our confidence intervals are very narrow. And in this case, they are narrow because we have just two groups. So that means with two groups, you have many, many people in those two groups. And with many people in those two groups, that means their confidence intervals are going to be very narrow. So you have achieved precision. But in trying to achieve precision, you have sacrificed validity. Why? Because you only have two groups. And because you only have two groups, you have residual confounding in those two groups, right? And so you have a problem now. So the question is, which should we prioritize? Should we prioritize precision or should we prioritize validity? Those are decisions that you, as an investigator, will have to make. It's your job. So please don't outsource that job to somebody else. You have to think very carefully. So in this case, instead of just saying less than 50 or greater than 50, we might say, okay, let's break down age into smaller discrete values, right? We can say, for example, 10 to 20. We can say 21 to 30. So that in these groups, we still have some reasonable number of individuals. But at the same time, because we have so many categories, that also takes care of the confounding by age, right? Because what is happening in your analysis is that the analysis is being performed within each group separately, and then we now get their average. We now pull them together. That's what's actually happening in your software, right? It's calculating estimates within each stratum separately, and then pulls them together to give you a weighted average. So when you now have just two huge groups, well, this group is like one very, very heterogeneous group. So there's still confounding within that group, right? So you still have confounding, even though you attempted to do it. And this is what we call residual confounding, because in this case, you attempted to control for confounding, but you didn't do a very good job. All right. So this is what, these are the things that you'd have to, first of all, sit down and do before you even attempt to upload the data set. See, we've been talking for close to 45 minutes. We've not talked about any data set. We've not talked about any software, because that is secondary, right? The ideation for research is the most important step that you'll have to carry, right? So please don't just jump into data and like, okay, where's the data set? No. Before you touch data set or do anything, you have to ideate first and foremost, right? All right, now let's get our data set in and explore it to see, you know, how we then proceed with that. So I'm going to go over to my data set now. Oops, I should not have closed that, but anyway. All right, let's upload the data set now. I'm going to start a new project, and I'm going to call this day 2 of research workshop. And let's proceed to our data upload. So this is the data set we're going to use. All right, so our data set has been uploaded. So the first thing when you upload a data set is not just to jump in and start analyzing. You want to inspect the data first, right? You see, medical school, they always taught to you IPPA, inspect because, whatever, I've forgotten all those things. So always inspect your data first, right? So you should have an idea of what's in your data set before obviously you have an idea of what is there because it's your data set. Don't just assume that any software read your data correctly. Assumptions can kill, right? So first thing first, you import your data set, check the number of columns. The columns are the variables. Is it what you expect to be there? Check the number of rows. Is it what you expect? You don't need to know the exact number, but obviously you should be scared if you saw only a row of 1. That makes no sense. Like, oh, it means that the software somehow read, and that's not impossible. That happens quite commonly. The software somehow read every observation as one long row. So again, check your data set dimensions to make sure that it's what is there is what you expect. And then make sure that the data you've read in, the number of missing values are consistent with what you believe, right? If you read in a data set and everybody has the exact same number of missing values for every, well, that is a red flag. That suggests that something wrong is going on. Also, if you read the data set that every variable is of the same type, right, and that does not align with your understanding of a data set, then obviously that's something wrong. So when you upload your data, take some time to get to understand the data set. Like, What are the variable names? Are the variable types consistent with what you know? Are the number of missing values consistent with what you know about the data set? Then try to visualize the data too, right? Visualization is such a very, very key aspect of data analysis. It allows you to see the distribution of variables to test assumptions. So again, click on the visualize button and look at, all right, is this what I expect? And does it make sense? You can switch the type of plots and examine accordingly to make sure that things are as they are supposed to be. You can also look at the summary. This is the summary button here that tells you the summary statistics for continuous variables. The platform displays the mean, standard deviations, and the 5-number summary. The 5-number summary are a set of 5 numbers that gives you the distribution of a data set. They are the minimum, Q1, median, Q3, and the maximum. So we call that the 5-number summary. So check that carefully to see that it aligns with what you expect accordingly. It is then and only then that you can now proceed to say, okay, I want to now start my analysis. Always inspect your data set first. Now, let's now start preparing our outcome variables for analysis, right? From our ideation, we agreed that we would prefer to have lab measurements, lab or exam measurements as opposed to self-reported. So here, if we look at, diabetes, for example, we have a self-reported measure of diabetes here, yes or no. But this is enhanced data, so it has information on lab measurements too. So here we can recode these variables so that no and yes are 0 and 1. So let's do that here quickly to prepare our data sets for analysis. The biggest part of analysis, of analyzing a data set, is not even generating the results. It is preparing your data set for analysis, right? So you want to make sure that if you are going to use a variable as an outcome, that it's prepared accordingly. So for example, if it's a categorical variable that we want to estimate its prevalence, we want to make sure that it's in the form of 0 and 1. That's a binary variable. So here I'm going to record this variable and classify, just change no to 0 and yes to 1. So that makes it binary. And so once I do that, I'm going to let me make this. In general, when you are preparing your data set for analysis, try to avoid this button here. Replace the original variable. That is always very dangerous, because if you have a data set and you replace original variables, well, what if you need the original data set? Well, hopefully you have it saved somewhere, right? But in general, it's something you want to avoid, like making changes to a variable and replacing the original. You always want to create a new copy of that variable. So for example, I could just call this diabetes self-report, right? So that it's very clear what it means. So here's binary. 0 means no, and 1 means yes. So I'm going to save that variable as my diabetes self-report. So here, so you can see that it looks different here, even in the icons. This is indicative of that it's categorical, but here it's binary, 0 and 1, as a very specific type of categorical variable. So now let's look at the outcome. The outcome here is diabetes, and we're going to use the lab measure, and let's recode that. So we're going to use the cutoff of above 120 based on previous studies. So I'm going to click at 120, and so individuals above that cutoff, this may not be super accurate in terms of the actual biology, but again, this is just a demo to show us how to think through it. So you want to make sure that it's your job to review the literature and review past papers to ensure that the cutoffs you're using are consistent with clinical diagnosis, right? But again, this is just a demonstration. So we're just going to confirm the cutoff. And so now the platform has split. So individuals with the cutoff 120 and above are in one group, and those in below that cutoff are in another group. I want to record this as 0 and 1 as well. So I'm going to edit the label and change this to 1. And edit this label and change this to 0. I want to make sure that it's a binary variable. So I'm going to call the name of this variable diabetes lab, right? So that's individuals diabetes status based on their lab diagnosis. So let's proceed. And then, so let's look at the variables that we have. So here we have created 2 variables so far, a measure of diabetes based on lab or objective data, and diabetes based on self-reports. Try to have a standard format for your own format preference. So this is a very disorganized format. Here I'm calling it diabetes, here I'm calling it info. Make sure things work for you by following a consistent format so that it's always predictable, right? But for now, we're going to leave it. But in your own work, make sure things are a bit cleaner and easier to follow. Let's say we also have a variable like cholesterol levels. Let's see if we can. So that could be argued to be a confounder as well. And so here we want to record that. Maybe we want to have a cutoff as well. For the sake of this demonstration, I'm just going to use a cutoff of 200. So individuals with 200 or above, let's call this, and I'm just going to leave it the way it is, so it's descriptive. And let's call this, give this new variable a name. Sorry, I'm zooming out so that you can see it in context. All right, and then you want to make sure that your categorical variables are recorded properly, and you can see them very well. So for example, if you have race, this takes us back to the issue of the trade-offs between validity and precision, right? You want to make sure that you have sufficient numbers in each group. Never proceed with, in general, never proceed with a group that is less than 50 people. If a group is less than 50 people, then you should collapse it with another, because the size is just too small to provide estimates that are precise, right? So it's always that balance between, should we prioritize validity by having a lot of groups so that we don't have residual confounding, or should we prioritize precision by collapsing groups so that we have fewer groups? Remember, those two guys are saying very opposite things. One is saying, let's have more groups. The one is saying, let's have fewer groups. Let's have more groups so that we don't have residual confounding. Or this one is saying, let's have fewer groups so that we have precise estimates. It's always a battle between those two. So it's your job. Please, don't come and ask, don't export that decision making to somebody else to say, hey, what should I do? Well, you should think and say, well, what do I prioritize more? So those are things you would have to decide in your study accordingly. If you need to collapse groups, well, it's just a matter of just drag and drop, and that collapses those groups accordingly. In our case, we're going to leave that variable the way it is and not collapse at all. So I'm just going to cancel this operation so we can proceed. Now, let's now proceed with our analysis. So let's say that we have everything we need now. We have our exposure well defined. Our exposure here is periodontal disease. And we can see the variable here. We have our outcome, which is diabetes. We're going to use the lab as our primary outcome. And then we have our confounders well identified. We have cholesterol level, we have sex, we have race, ethnicity, we have education. Let me see what I hope we have education. Yes, we have education. And so now let's proceed with our analysis, see how everything would then come together. Let's see. All right. Now, if you don't know what you're doing, we always suggest that you should stick to this analysis wizard. The analysis wizard is your friend if you are confused or if you're not confident in what you're doing. So here, we're going to just say, assume we've never written a manuscript before, and we need to write a paper today. So let's stick with that scenario. So I'll come to the analysis suggester. And first things first, I have to select the single most important outcome variable for my analysis. You can only have one primary outcome in a study. Primary, every other outcome can be a secondary outcome. And here, the platform shows you some justification for the instructions provided. So here it tells you that every study needs one main outcome, just like a ship can only have one captain. We try to explain things in simple ways so that everybody can understand. If you have several possible outcomes, choose the most important one as your primary outcome. The others can be listed as secondary outcomes. Your primary outcome should be the variable that best represents what your study is about, the one you'd mention first if asked for a quick summary. Factors like impact, prevalence, stakeholder interest, and data quality can guide your choice. The last point is very important because you might have this variable that you like, but it has a lot of missing values. Well, that means that it's not very suitable as the primary outcome, is it? Then you may have to settle for a second best, right? But those are reasons, those are some of the considerations you want to put in. And so, but bottom line is that you can only have one primary outcome. The way we've also structured the flow is to have a causal framework in thinking, in causality, in causal epidemiology. We talk about your exposure, your outcome, confounders, and all of those things. So if you're going to use this tool, we actually force you to adopt a causal thinking, even if your study is not, even if you're not interested in making causal interpretation, but it still helps you, and say aim for the moon. If you miss, you might just hit the birds, right? So that's the framework here. We force you to adopt that framework so that your study is structured better. So here you pick your primary outcome. In this case, that's our diabetes as measured in the lab, and that's binary variable. Next, we have to choose our secondary outcomes, right? What are secondary outcomes? Well, here it says we also ask you to select at least one secondary outcome. Secondary outcomes add depth. They help check whether results are consistent and they strengthen your story. For example, variants of the same outcome. For example, if we're using cigarette smoking as a primary outcome, secondary outcomes could be cigar or chewing tobacco use. It could be the same outcome measured in different ways. For example, the secondary outcome could be self-reported smoking, where the primary outcome was biochemically validated smoking, and so on and so forth. So the last part here says, when these different measurements point in the same direction, we call this coherence, right? So when your primary outcome and your secondary outcome are pointing in the same direction, that's what we call coherence. So it makes your findings more credible. That's why we ask you to supply a secondary outcome. Here, I'm going to supply a secondary outcome as my self-report. Actually, we should have created a variable called any diabetes, whether it is lab or self-report. Let's actually create that quickly. Let's create a measure quickly. Data processing, let's come to composite variables. And let's create a variable that is any diabetes based on either lab or self-reports. Let's do that. Let's do that. So here we're simply saying that if you report 1 for your lab or 1 for self-reports, then we're going to merge those two. So either of them, then let's merge that. So 1 or 1, so we're going to drag it to the side. This is the side that contains the final categories created. And then for all the other remaining, so we're going to assign them into a separate category and exclude missing values. So now we have a measure for any diabetes, whether it was self-reported or diagnosed in the lab. So let's edit this label to 1. And let's edit this one to 0. And let's call this any diabetes. So this is whether it is self-reported or measured from a lab. All right, done. Now let's go back to our analysis suggester. Now, if there's this feature here that I should point out to you, I didn't use it there, but this button here allows you to minimize, so that if you're in the middle of something, you don't have to close it, right? So this is the button you want to use when you want to do that. But anyway, so let's come back here and select our primary outcome. We selected was diabetes measured in the lab. Our secondary outcomes are any diabetes, as well as diabetes based on self-reports. Now, next, we are asked to choose the main predictor or exposure variable for our analysis. The justification here says the primary predictor is the main factor whose effects on the outcome you want to measure. For example, if your study looks at the link between smoking and lung cancer, smoking is a primary predictor. Even if your study is exploratory without a clear causal question, you should still select the most important predictor. This allows you to apply a causal framework when giving you. This allows us to give you structured guidance based on causal frameworks. So that's why we ask you to select a predictor. So in this case, our study has a clear predictor, which is periodontal disease. But I was saying that even if your study is exploratory, like you're saying, oh, what are the factors associated with diabetes? And you're not necessarily specifying one particular factor as a main exposure, you should still select one of the factors as your main predictor. That way you're structuring your research question with the causal framework. All right, so let's select periodontal disease here. Periodontitis. So that's our main exposure. And then lastly, it says choose the main demographic variables or other key covariates in your data set and specify their type. Again, let's go to justification. So here it says, be sure to include basic demographic variables like age, sex, race, income, education. These covariates help to show how the outcomes differ across key groups. They provide context and they strengthen your interpretation of results. So that's why it's important. All right, now let's select our variables of interest here. Let's use, sorry, my screen is very narrow. Let's use cholesterol lab, which was an ordered variable. Then let's add more. We have smoking status, 0 and 1. I think we had age. Let me search for it. Age. We had sex, I believe. We had race. We had education. And what else? Let's scroll down to see whether we had any other things we forgot. Okay, I think I saw a variable here, like comorbidities or other medical conditions, which could be interesting as well. So, in your analysis, that's definitely a confounder you want to include. But for now, let me just search through if there are other. Okay, this is fine enough for a demo. All right, so we'll select the variables. These are all unordered categorical variables. All right, so this is the hardest thing you have to do, right? When you're writing a paper on the Chisquares platform, this is the hardest job that you have to do. Everything from here is smooth sailing. Now we have to click this button for the platform to then suggest analysis for us or suggest tables for us. It has finished doing that. So here it has said, the platform is saying that our study will have 4 tables. Table 1, table 2, table 3, table 4. It says that table 1 should be characteristics of a study population. These are the variables that will be assessed in that table. Then table 2 will be overall and stratified prevalence estimates of the selected outcomes among the study population. This will be the outcomes here. Any diabetes measured in the lab, and this will be the tablet, the variables that we're going to stratify by. And then it says table 3 will be an adjusted odds ratio calculated in a binary logistic regression model, assessing factors associated with diabetes measured in the lab, right? Now, all we need to do literally is just to click run this analysis. That's all we have to do. So here, let's click run this analysis and let's click estimate. So the platform will run the analysis. It has finished running the analysis. So here, this is the formatted table. This tells us the N, and this tells us the percentages. So now we have to now push this to our results, right? So let's do that. So let's push the results to our manuscript. So here, we don't have a manuscript yet. So we're going to create one here. An academic manuscript. Let's start writing. Let's give it a title. Let's call it the relationship between periodontal disease and diabetes among US adults. That's our title. The aim, let's ask AI to generate the aim for us. This is the first time in all this process that we're using AI. We don't use AI for anything that has to do with data analysis, any kind of data, right? But for low-hanging fruits like this, yeah, we definitely support the use of AI. But analysis has to be free of AI because it must be 100% correct 100% of the time. And that's why we don't use AI in analysis. So let's select some aims here. And let's start writing to create our document. So now our document has been created. Now we can push the results there. So the platform takes, of course, we selected that we want to push the table and the figure and the text. So all 3 have been pushed. At this point, we can either go to view the document, or we can just stay and push the rest and then go and see them. So let's just finish everything here. But so here is a table that was generated. Here is the plot, the figure that was generated. And here is the text. The platform writes out the results for each analysis it does. So for each analysis it does, it gives you a table that is formatted for publication. It also gives you a figure of the same data and also writes out the results for you. And again, none of this involves AI. So in the write-up, it provides a methodology because obviously as we're selecting variables, the platform is tracking those things. And it uses that to write out the methodology of what you did. It writes out the results that it found from the results that were generated. So, and then it also writes out the limitations based on what you can see. Again, none of these processes involve AI. That's why we provide here very conspicuously that no AI is used for data analysis on the Chisquares platform. All analysis are automated with statistical code. All right, now let's go ahead and do the other ones, the other tables, and then let's go and see what our manuscript looks like. So we have done table 1, and that's why you see it has changed to view history as opposed to analyze, right? Now let's go to table 2, which is overall and stratified prevalence estimates of the selected outcomes among the study population. Again, let's hit on run this analysis. Everything has been set up. If we want to change the preferences, we can come here. We can select the number of decimal places. We can choose whether we want to suppress unreliable estimates. In general, we suppress estimates with relative standard errors of 30% or higher as being imprecise. That's your choice. You can also choose whether you want to display the results as percentages with 95% confidence intervals or percentages with standard error. And then the platform will implement accordingly. For now, I'm just going to run based on what we have here exactly. So I'm going to estimate. We're analyzing among the whole population. That's what we have, entire data set. If our analysis was only among a subset, we will have selected subset. So again, here the platform has written out the results as a table. We have the plots. We have a text. A very important thing to note, for prevalence estimates or descriptive statistics, when the platform is writing out the results here, it does something you have not even asked it to do. If you look at here, for example, let's say, let's look at this sentence. Differences in any diabetes lab, and diabetes self-reported. Let's make it smaller so we can see clearly. So differences existed within levels of age, cholesterol lab, education level, periodontitis, race, smoking, and sex. So as it is reporting, it is actually doing statistical testing for differences in those outcomes within those groups. Because obviously it makes no sense reporting differences that look different but are not actually statistically different, right? This is a scientific manuscript, and so you never asked it to do statistical testing, but it did, right? So you can see that the only results that are significantly different are reported in here, right? So and that's one of the reasons why we cannot use AI, because AI can make mistakes and we can't allow that happen. The writing also of the result is done in a way that is extremely stochastic, meaning that if you and I were to analyze the same data, the results obviously will be the same in terms of like 34.61, but the formatting and the framing and the language will be different each single time, right? And we'll make use of random theory, statistical random theory, to achieve that, such that there's a high degree of, randomness, or the output itself is highly stochastic. In fact, the chances of getting the same wording is 1 in over 1 billion. It's almost impossible based on how it has been implemented. And again, these are reasons why we have to use algorithms or statistics and not AI to achieve those kinds of effects in engineering. All right, now we have our results here. We can now push this one also to our results, our manuscript. Again, this is our manuscript that was selected. So we're going to select that and push. All right, that has been pushed. Now let's go to the next table. So all you have to do, your job is just say, all right, here are tables, table 1, table 2, table 3, table 4. Your job is just to run and push. So here we have table 3, which is a regression analysis. Let's open this and run it. And then, so here it's saying when the variables are recoded, or the variables are in a form where they are not conducive for analysis, the platform displays it for you so that you can recode them accordingly, so that it doesn't send you on one way to say go and record and then come back. So everything is done very seamlessly. So in this case, we'll just click on this button and then record. But just to show you another way to access that, so that we're not catering only to a particular demographic. If we do not want to run it this way, the same results that we just ran now, you can also access them from this button, this estimate, right? So that's another way for us to access the same, functionalities. You would come to estimate and you select the kind of analysis you want to run, and then you click on, for example, regression. The only advantage is that with analysis wizard, everything is structured, and so it's very specific. It's built for you 100%, so you don't have to start wandering around. So, but if we wanted to, for example, set up our analysis here, for example, we could easily set it up here as well, right? Where we'll select our outcome variable, for example, any diabetes and do the exact same thing. So that's just show you that, you know, if you don't want to go to the route of the analysis wizard, you can also access it from here. All right, let's take a peek at our manuscript to see what is happening there. On the interface here, you can access the manuscript you've been pushing by this button here that says switch to manuscript, right? So we click that button and it shows us all the manuscripts that are available. So this is the one we're working on. So we can click there to go to the manuscripts of interest. All right, so now this is our manuscript that we've been pushing content to. So let's resolve the variables. Resolving variables means that we want the variables to appear in a way we can understand, in a human readable format, because they are initially written in machine readable formats. So here too, we want them to look like things we can read and understand. So we'll resolve it so that they are human readable. So this puts them in, these are the original variables we had. You see, they are here. So every content, as you push content, what happens is that regardless of the order in which you push the content, the platform rearranges material dynamically based on what we call packet IDs. So to put it very simple, there's a structure in which we write science. In general, we have 1 variable, 2 variable, 3 variable. In other words, univariate, bivariate, multivariate. In general, that's the order in which we write science. So it doesn't matter the order in which you pushed any particular content. The content that you just push will crawl its way through the document and go and insert itself where it is supposed to be. So you don't have to worry about, oh, geez, where is it supposed to go, right? The platform takes care of that automatically. And of course, that is all without AI. So this is the content we have pushed so far. When we are ready, so right now, this is just telling you that don't worry, it looks ugly and haphazard, but when you're done with everything, then you can clean the manuscript. Here is what cleaning it looks like. When you click here, you supply the names of the variables. So for example, periodontitis, I will say, this is periodontal disease. I will supply what each of these names mean. And when I'm done, the platform will, again, go through all the occurrences of those names and replace them in context, right? So that, you know, everything now looks clean and makes sense in terms of just the flow and the readability. But you should only do that ideally when you're done so that you do it once and for all time. This is just a demo, so I'm just going to give you the high level, understanding of specific items so that we'll cover all of the things that you need to know so that when you're practicing with your own manuscript, it makes sense to you. All right. So now we've pushed some of the work. We didn't do all the analysis, but notice that the analysis tray comes with us. This analysis tray came from analysis. We had some suggestions for tables, if you remember. Not all of them. We only pushed 2. Yes, somebody has a hand. Okame. Are you able to talk and ask a question?
Prof, how about you take questions at the end of the session?
All right, sounds good. Alrighty, thank you. All right, so so far we have content in our methods and in our results. Again, they're not yet cleaned up, but they reflect content we have just pushed to the manuscript. Now, let's talk about how to generate content for the rest of the other sections, which is the introduction and the methods and the discussion. Now, how do those parts work? Well, those parts here allow us to generate this content with AI input. And there are 2 ways you can choose. You can choose to, well, there are 3 ways. You can choose to ignore AI completely and just come and type your thing and say, this is my introduction, which I am going to type manually, all by myself. I find typing very, very hard. I hardly type. I use dictation all the time. So for me, it's easy to just say, all right, I want to type. I mean, I want to write, but I want to type. But I write so much that I can't be typing all the time. So, and that's why we have a dictation feature here. You can simply click the button that pulls up for those of us who don't love typing. And even for those of you, if you're not used to dictations, please, this is something you want to, I think that's one of the greatest boosters of efficiency and productivity, the ability to dictate your notes or dictate your work in general. So in this case, one of the clever ways we've done about it is that a big problem with new writers is that they will write one line and then they will go and look at that line, admire it, change the font. It's like, no, that's not how you write, right? You have to follow principles of FBR, fast, bad, and wrong. When you're writing, you can't worry about whether it looks pretty or not, right? And so in the dictation feature here, when you start dictating, the platform doesn't show you what you are dictating because you should just focus on your dictation, right? When you're done with everything you have to say, then you can stop the button and then the platform will then transcribe your notes for you. That allows you to focus on lifting the ideas from your brain and putting them on paper instead of you worrying about how pretty they look, because this is not the time to make things pretty. We first generate the content first, and then we'll make it pretty. So when you're done with all your dictation, all you have to do is to click this button to say, stop it. Platform then transcribes those notes for you so that you can be able to, work faster. So this is what we have here, right? So the moral of the story is that the platform gives you many, many, many ways to generate content. AI usage is a choice. You can choose to use AI. You can choose not to use AI. If you don't want to use AI, the platform is by no means an AI platform. You can do everything on the platform without AI usage, actually. And so if you want to, if you want to use your dictated notes, you can push the manuscript or you can just copy and use it accordingly. And it's always saved so that in case you come back again, the transcription you had will still remain there. And should you add more notes to read, it's going to be appended at the bottom so that your notes keep increasing, even if you don't have the time to dictate all of them at once. So that's how this transcription feature works. I find extremely, I don't know how I can survive without dictation on dictated notes, but that's my go-to device all the time. All right, so that's that. So you can type your notes yourself. So for those of people who are worried about AI, yeah, you don't have to use AI. AI usage is a choice. And we don't believe that, the way people carry on about AI as though it's a dirty little secret that has to be hidden. That's not our philosophy at all. Instead of hiding AI use, we believe in actually disclosing it. So when you come to check here, you can view AI activity by clicking this button, and it's going to tell you all the places that you have used AI. The purpose is not to, shame you or whatever, but it's to help you pay closer attention to those places, right? Knowing fully well that AI makes mistake. So here, for example, you can see AI. So far we have not used AI at any part of this manuscript so far, right? So that's why you see everywhere it says AI not used, because we've not used AI. Now, if you want to disable AI completely, you can. Let's say disable all AI. So the bottom line we're trying to say is that the choice whether to use AI or not is a deeply personal choice. And you shouldn't be asking people, oh, are we allowed? The question of are we allowed always makes me chuckle. Like, are we allowed? Allowed by who? So it's your personal choice whether to use it or not to use it. That's completely up to you. But should you wish not to use it, well, there are many, many ways you can still develop a manuscript. Now, let us say you want to use AI for your work and you want to generate the other parts of your manuscript with AI. How do you go about that? So let's come back to this one here. There are two ways to go about AI, in those sections of a manuscript that are supported with AI. You can have the AI first or human first approach. AI first approach simply says, well, I actually don't like writing. I mean, like I'm not very good with coming up with my own concepts. Like I have the ideas in my mind, but putting them on paper is hard. It's easier for me to edit, right? So if I'm that kind of person, you can now say, oh, AI should take the first stab at just giving me something to then edit according to what I want, right? So that acknowledges that we're all different and people write different ways and people have different preferences, right? It's not one person's job to be policing what other person, what somebody else prefers, right? So for people who find it easier to then work on an initial draft, that's why they have that button there, so that AI takes the context. And what do we mean by the context? It takes the title, the topic. So in this case, it has taken the title and the concept and all of those things and has generated something, right? Now, is this perfect? Not at all. In fact, we warn you here. We say that we recommend using this AI-generated output as a starting point and editing it thoroughly to ensure it meets your needs. Any references included may be inaccurate. So use the reference manager on the main platform for valid citations. This content is an initial draft, not a final product. And as the author, you are responsible for the final product. This is provided as a service to help you. So please don't say, oh, the Chisquares platform was the one that gave me this introduction. No, it's your work. You are responsible for it. So you should act responsibly as a scientist and use that as just a first draft and then edit the life out of it to make sure it suits your purposes, right? So that's the introduction here. So that's the AI first approach. So in this case, AI gives me content and I can choose to edit it. I can choose to say, oh, I'm gonna delete this part. I can edit however I want, right? And then when I'm done, I can then push to my manuscript, right? So the content then is pushed to the manuscript accordingly. So let's now try the second approach. So this is the content here. The idea is that you finish your generation and then you do your citation, right? We're going to talk about the citation later. So now, what if I don't want to use the AI first approach? Well, that's where the second approach comes in, which is the other one we mentioned, right? Where you can then provide content. Let's delete this. So this is the methods. But the same principle applies in the methods too. Let me not skip over it, right? The methods, we have structured in such a way that makes it look like a form. It is easy for everybody or anybody to fill a form. Like everybody knows how to fill a form. So it asks you very specific questions like what, when, and how. So for example, what was the study design? You select, oh, this was a cross-sectional study, right? You select that. Then what ages were eligible for the study? You can say, oh, well, the study included persons this age or, all the ages involved, right? You select all of them. Then it says, what was the study setting? Well, it was a household-based survey. This is incredibly useful for people who know what the study is all about, but they don't know much about grammar or how to write things. Because this is the basic aspects of a study design, which the platform will then use to just feed it to AI for it to now say, all right, you have the key information now. Write it in the standard way that we write scientific manuscripts, right? So your job is to provide the information. So here, how were participants selected? I can say they were selected with stratified sampling or whatever the sampling approach was. How were data collected? They were maybe face-to-face interviews. The location, where was it? You provide a country. and when did that collection occur? Again, you provide information. The idea is that please provide elements of person, place, and time. You find that most times researchers will provide some of the elements, but forget some. The goal of this is a very simple interface, but the goal is to make sure that every single element that we need for comprehensive reporting of a methodology is provided by you, right? Don't worry about the language or the framing, right? Your job is to provide the correct information. And then AI's job, this is a partnership between you and AI. So AI's job is to take the information that you have provided and make it look very nice and standard. Your job is to provide the facts, right? So this is the approach we have used. Let me just finish. Let me select a country, the United States, or let me just select the first country right here on the list. When did that collection occur? Let's say 1902, all right? Obviously, these are not factual entries. The goal is just to demonstrate to you. So once you provide all of those things and you click on generate methods, the platform takes all of that information and writes out the appropriate section for you. And then you can then push to manuscripts. Again, you have the warning there that says, note that this is AI, it's your job. It's your job to make sure that you review through that carefully to make sure that everything aligns properly. The same thing applies to the discussion and the conclusion. Is exact same framework. Everything is structured like a form because everybody can fill a form. Forms are easy for everybody to fill. And that way the platform develops those sections of a manuscript. Now, how about references? How does that work? It's your job to supply the references for your work. And so the platform provides you with, let's call it the citation here. There's integration with PubMed and with other databases, which allows you to search everything from one place. So you don't have to leave here and go to PubMed. You can search PubMed directly from the platform. So here, for example, you see this is PubMed. And so if I want to search, I can enter a search term and look for it and type, right? Now, once I pull my results, citing is straightforward. All I need to do is select the sources that I wish to cite and just click on cite. And those are then added accordingly to my manuscript at the point where I wish to cite them. So right now, it's added. It first of all adds them to your citation library, and after adding them to citation library, then adds them to your document. So here, for example, I've cited 1 and 2, and so you see the in-text citations here, the inline, but also the references are added at the bottom of your work as well, right? You can switch from one referencing style to the other simply by coming to settings and reference style, and you can change it from, let's say, AMA, which is currently the case now, to, let's say, IEEE, for example. And, the platform will implement, the requested change accordingly. And so that's how you cite work on the platform. There are other features here that are also designed to, let me walk you through some of the remaining features there. It's a collaborative platform. So that means that many, many people can work on the same platform. So that means that you should be able to add authors. When you want to add authors, you come to author management. And obviously you're the author here, so your name is already there. But you can add individual authors, for example, by copying a link and sharing with them and say, hey, just add yourselves. If you have a lot of people, you don't want to be adding them one by one by one. So you can just copy a link and share with them and say, all right, onboard yourselves. And you can kick out people who are not eligible if you so desire. So that's how you add co-authors. Co-authors, when they're working, you can see everybody who is working in real time. You can also see everybody's contribution. The platform tracks everybody's contributions in terms of number of words and how long this, number of hours and number of words. So if I added, let's say 10 people and, somebody added just 2 words, I'm going to know that, oh, this one just added 2 words. Or they spent just 2 minutes on the platform or on the document ever. And, the platform uses that to determine the order of authors based on the magnitudes of the contributions. But of course, you can override that and set the order manually by yourself. So that's what you have in authors. It allows for, for you to add people to work in a collaborative context. And then you have forms like ICMJ forms. The platform allows you to, authors to complete their forms on the platform so that everything is very seamless. This part here allows you to add sections to the manuscript. So there are some sections that are added by default, like introduction and methods and all of that. But you may want to add your own sections. You may want to add significance, a statement of a problem, or some other one. Or you may even wish to add a custom section that does not exist here. Or you may want to add an appendix, right? This allows you to have all of that done appropriately. You can obviously download your work as a document in a Google Docs, Word document, or a PDF, as the case might be. Then on this side here, style, let's look at some of the things there. You can change the font type. You can change the spacing of characters, depending on how you wish it to look. This just gives you a preview of what it's going to look like when you click the button apply, right? So you have letter spacing, you have line spacing. Line spacing is like double spacing or things of that nature, and indentation of paragraphs. So you can apply all of those changes as you so desire. Then you could also choose to have let me move this out of the way. A title banner. A title banner is not really necessary for scientific manuscripts, but you might be doing some other document type that you want to have a banner at the top. Maybe add your logo to it, add a title. You can do that accordingly. So here, this is what the banner looks like. I can choose to add, for example, elements like a header that says, this is my title banner, and choose to make the fonts bigger or even bigger than that. I choose to move it to the center. I can choose to add, for example, other elements like a logo and things of that nature. Let me see if I can add a logo to it. Why did I go on this wild goose chase to look for a logo now? Alrighty, let's see if I can find the logo. All right, you know what? Well, I'm sure you guys get the point. So you can put your logo, if you have a logo. So you can move that anywhere. And you can add subtext. But it's this can be very useful in maybe not manuscript exactly, but just some other kinds of documents. All right, let's move on to other features that exist here. Subtitle, if you want to have your manuscript to have a subtext. All right, let's move to other features. Language allows you to expand a particular text or make it contracted, or to paraphrase it accordingly. You can also translate accordingly for any selected text. The check allows you to do a pre-peer review if you want the platform to review your manuscript before you send it to a journal to identify scientific issues that may be wrong with it before reviewers pick you apart. sorry about that. Longley, what happened?
You did that deliberately. Don't act like you don't know what you did.
No, actually, right now. I'm actually in Tufts University right now. I'm on a guest Wi-Fi, so they kick you out at intervals for whatever reason. It's very absurd. I think at every 1 hour they kick you out, and so you have to resign. So that's what happened. Sorry about that. Okay, where was let me share my screen. So am I sharing my screen now?
No, we're seeing the Tufts Wi-Fi.
Oh, okay, already. So all right. So maybe that's a sign that I've spoken enough. I've been talking all day. So maybe the stars are telling me that you've talked enough for today. All right. The handwriting feature allows you to create, if you create a document, maybe handwriting, you can have an equation, for example, and we have an equation like, some handwritten equation that I want the AI to detect, right? And then in that case, you write it down and say, all right, transcribe what that means. Maybe you're feeling so lazy and you don't want to type it manually. Or it can just be signature, where you type your signature and, and insert at a specific point in the document, right? Either use case suffices, or you can just save it to the library, so that you can always use that signature in future documents. So it's not just about manuscripts, right? It's about, document management in general. So sorry, let me move this out of my way. It's just this Zoom thing keeps blocking all right. And let me move this one to minimize this. Much better. All right, now let me quickly show you some of the settings and the other features here. The document here allows you to lock or unlock sections. You may wish to, in a collaborative environment where other people are working, you may wish to say, well, I don't want anybody to make any changes to the results now or to the discussion because I'm working on it. I don't want people to keep, making changes. So I can lock those sections while all other sections remain unlocked, right? So that means that people can make changes in every other place that is unlocked. But the parts that are locked, they can't modify them because those parts are locked. So that's what the locking does. It allows for a managed workflow in the presence of many collaborators. So you can see here that it shows the locked icon, right? That means that I'm the only one who can work as the owner of the manuscript of a document. I'm the only one who can work on that at that moment. So that's the problem we're trying to solve with that lock or unlock. It allows for manageability of a document. Of course, you can also unlock sections that you've locked by just coming here and, saving. So that's what that does. Then you have insert. You can insert a blank page. You can add a watermark across a document. You can add symbols or equations to your document. You can, geez, this internet is horrible. All right, you can add equations, symbols, Greek symbols, currencies to your work. That's what that means there. You can also insert audio or video into your document and play it from a document. So that's that. Then let's look at some of the quick settings here. Project title and aims, that's pretty obvious. The managed document allows you to be able to set limits in terms of the word count limits and other limits for tables and figures so that the platform can enforce them for you. Then you have reminders and notifications for authors. You know, you can set for the system to remind authors. If you're working in a collaborative environment, you can set the task. You can say, alrighty, I don't have pending invitations here now, but if I invited some people to my project and they have not yet accepted, this pending invitation says, send them automate reminders that tells, reach out to them, let's say once every 2 weeks, and say, hey, this just remind you that you have been invited to participate in this project. Again, I don't have collaborators here. That's why I can't select this. But here, this allows you to, if people have accepted the work now, I invited you to join my work, and you came and you have not contributed one single word to this document, this allows you to, this allows the system to send reminders that says, okay, sure, that's fine, yeah. That allows the system to send reminders to say, hey, you accepted this work, but you have not yet contributed, right? So that then they can make the contributions as needed. So that's what you have with the pending contributions, pending invitations. So that's very helpful for people who like to accept invitations but not do the work, so that the system automatically reminds them. Then we'll talk about the AI controls. Again, the platform can work without AI. If you can choose to say, I want to switch off all AI and switch it off, or you can select specific parts that you don't want AI. Maybe you are working with a student and you want to make sure they don't. I mean, it's up to you. The tools are provided for you to use as you so desire. And if you're working with collaborators, you can, communicate with them and send notes and comments accordingly. Now, this is for a manuscript we're creating brand new, but then the platform also allows you to import documents that you have worked on externally. One of the biggest problems in science is how to manage references. Maybe you submitted a work to a particular journal and the work was rejected, and now you have to reformat the references. Typically, you have to do that manually. The platform solves that problem such that when you have a document, you can simply import it and, it automates all of that process of managing the references for you automatically. So let's say I had a document here that I already had developed outside. I can simply upload the document. If it's an academic manuscript, let's continue. Let me find the document. Let's say, let me use this one. And the aim can generate that with, the title is, let's say, the design of field experiments in epidemiology. All right, and then let me just quickly generate an aim. Just to show you how you can, if you're working with a document outside, how you can also manage that process effectively. All right, so here I can select an aim here. Now, the options here, you have 3 options. Auto-split this document. Auto-split means that my document has structured sections like a scientific manuscript, and I want the platform to split them for me. Manual split means, well, my document has sections, but don't worry, I'm going to do it myself manually. And then free-flowing means, well, my document does not even have sections. This is important because the platform it determines which type of document the platform will put you in, because different types of documents have different engineering requirements, and so we would send you to the right document depending on your choice. If you choose to say auto split, the platform will then respond accordingly to take that document, and it will attempt to split it. It will examine to see whether you have references. And for the references you have, it's going to grab those references. For each reference you have, it's going to run to PubMed and it's going to run to Web of Science and see whether that reference is legitimate and whether there are any parts of it missing. And it's going to do that for all the references. If it finds a reference and it goes to PubMed or Web of Science or other databases, and it finds the references, it compares to what you have, and if it's valid, it saves it in the reference manager. This is why this process takes time. It takes up to, we say 10 minutes, but it could take less, but it takes some time because the platform has to go through all that process of validating all your references. It is after it has validated all the references that now it allows to now easily switch from one reference format to the other. Right, so but you don't have to sit down and be watching it do this. You can obviously close the page and come back to it later. Now, let's say that, let me go back to the one here. Now, let's say that you're done with your manuscript. Let's just walk through some few features that you might want to know about before we take questions. So you have to pardon my internet here now. All right. What I wanted to show here finally was this publish mode, and the dark mode. If you don't like the dark mode, you obviously can choose to use a light mode. I find the dark mode very soothing on my eyes, so I hardly use the light mode. But that's your choice, obviously. When you're ready with your whole manuscript, you can click on publish here, and you have two options. One is to publish your work as a preprint on the Chisquares platform. The other is to send your work to a peer-reviewed journal. We're working with a growing number of journals to have a partnership where on selecting any of those journals, the platform will automatically format your work in the requirements of that journal and automatically submit it to them, so that you don't have to do all this work of manually formatting things, So those are some of the additional, but we're going to have some specific sessions on those in the future. This is just to give you a very high level focus on, more importantly, on the science, on how do you create the ideation pathway for a manuscript, and also then how do you execute it on the Chisquares platform. All right, I'm tired of talking now, so I'm going to stop there and take questions. So those who had questions earlier, please, you can ask them now.
And kindly repost them on the chat box. You're welcome to also raise your hand if you want to speak. So here's a question. How are you assured that your documents and contents are secure, not exposed to theft or loss or other risks?
Well, the only person who has access to your account is you. Your work is yours. Of course, if you invite collaborators, that increases risk. So that's something you want to take very carefully. The platform gives you the tools to be able to manage collaborators. So when you invite collaborators, you can assign them roles. Your author management includes roles. There are some roles that, if let's say I want to add an additional, I can select a role that reflects how much access they should have, right? And also in the settings here, let's look at the process of inviting collaborators gives you the maximum control over, what each individual should do. So if you look at the roles, let me go back to the roles quickly. There are different roles, and each of those roles has, carries different, degrees of access. So the bottom line is that you have access to all of your, we don't know what you're working on. We don't have access to your data or access to your documents. But when you invite collaborators, obviously that in of itself presents risks for you They are not necessarily our own problem because they are your collaborators, but we have provided the tools for you to manage those risks accordingly. So that's how the platform enforces that.
Daniel? Daniel Dudu? Okay. I suppose the platform looks like a web app. No need to install any apps. Is that correct?
That's correct, yes.
Thank you. What is the length of time the platform allows you to dictate at a time?
It's not length of time per se, but it's up to 5,000 words. So you have to be dictating an entire thesis. But for all practical purposes, yeah, you should not run out of dictation time. I handle all my work with dictation, and I've never experienced where I where I use up to the maximum limits allowed. So you have pretty much runway there.
Thank you. Is it possible to export data from SPSS to the Chisquares platform for analysis?
Yes. You can import data from any software into the platform.
For the documents, could it present the table of contents too?
Yeah, table of contents is, yes, automatically always presented. You can choose to maximize or not maximize it, depending on the if headers are found or what kind of documents exist there. So they're there. If it exists, it's displayed automatically, and you can choose whether to maximize or not maximize it.
What if you want to include pictures, diagrams, or flowcharts in your report? Does the platform also help?
Yes, it does. So for example, let's say that let's go back to this one we're working on. Which one was that? First of all, let's go back to the internet here is bad. Let me stop this. Okay, so that's so this is the so if you want to include figures or tables, you'd come to let me remove this element here so that we can see clearly. So you'd come to this here. This is tables. This is figures. So you come here and you can upload a figure. There are two types of figures in general. One is a figure that exists as a standalone figure. Second is you might have an Excel spreadsheet with many, many tabs, and each tab with many, many figures, like charts. So in that case, those charts are different from figures because figure is like static, whereas a chart is linked to some data. So in this case, if you have like one Excel spreadsheet with many tabs, each tab containing many, many figures, you can upload that. The platform will dynamically render all of the images for you, and then you can pick which ones you wish to include. So bottom line is whether it's a figure you have that is standalone or it's an Excel spreadsheet with figures, you can bring that in. The same thing applies to tables as well.
Thank you. I suppose that manuscript is different from thesis or research report. Does the platform generate just the manuscript or both?
A thesis could be framed anyhow, could be framed as manuscript. So those are choices that you, as the researcher, need to make. The platform gives you the tools to do document. You can choose to, and that's why here, when you start writing, you see the types of manuscripts given: academic manuscript, upload, but then you also have documentation, which is general purpose. It could be anything. And even in the manuscript, let's go back to here. Even in the manuscript, you can choose to say, I want to convert this manuscript to from a structured format to one that is unstructured, right? So if I have a document that is, let's quickly show an example here so you understand. This one here, documentation, allows you to just write in free flow and give subheadings, whatever name you want to call them, without the rigid structure of sections. So if I click this, and I start that, all I have to do is provide a title. Let's look at this quickly. Title, and then I start, right? Now, this just opens a plain document where I can just type, right? I can add tabs. Let's say I'm doing my dissertation, chapter 1. Let's say I'm even maybe a history student and I have, I don't necessarily have an analysis per se, but I just have a lot of text. I can just add more tabs. And add more tabs, right? So this is tab 1. I can call this, for example, chapter 1, for example. Let's rename this as, okay, here's rename. And call this as let's say chapter 1, right? And I call that one chapter 2, chapter 3. So in this case, this is I can create a document in whatever shape form I want. It's not restricted to formats that may have been created by the platform. So here you can do whatever you want. I can say, oh, this is I can add a color to it. I can choose a tab color. So that I want to make this red. And so the chapter 1 is reflected here accordingly because this is that chapter accordingly. And so all the content is now created based on what I want. And so this is a more loose flowing document that allows you to do whatever you want. And the same thing, you can still add analysis here, right? You can add results from the analysis here, but without being restricted in terms of the layout. So if you're writing a thesis or not even a thesis, just any general document that doesn't necessarily adhere to traditional formats, then you can use this. So that's the allowance the platform provides you in that regard.
Thank you. Abraham? Abraham, your hand is up.
Yeah, thanks very much, Prof, for the insight. A quick one. Mine has to do with the referencing aspect. Let's assume you have a whole thesis and then for the references, some of them are actually not falling in, are not in tandem with what you are looking for, but there's this kind of, there are inadequacies. So will the platform permit that you import everything? Won't you be limited by word count? I just want to find out, whether there's a word limit. Let's say you want to import your thesis onto the platform for it to at least ascertain the authenticity of the references. And then maybe those that are not actually adding up, find the right references and then let them go to the references section. Thanks and over. That's my question.
All right, thanks. So there are no word limits. A document can be 1 million pages. That's going to be pretty hard to read, but that's your document. Now, to be clear, the platform does not, if it comes across a reference that it doesn't recognize, it's not going to remove it. It's going to, it's your document. You are the owner. Obviously, there are some references that could have existed, but are just not found in PubMed or Web of Science or where we have looked. So the fact that we have not seen it doesn't mean that it's false. So it's your responsibility as the author to manage your references. So the platform will not say that this is wrong because it doesn't have that context for your references. But in terms of your original question, there's no limit to the number of pages that a document can have.
Thanks, Prof. Dudu?
Yeah, Prof, thank you so much. I've enjoyed the session. I'm really grateful. My question has to do with the AI part you mentioned on the platform. To maybe set it off, when it comes to AI, I am an advocate of the uses of AI. And for me, I disagree with anyone who feels that AI has no business in the education sector. But then what I want to know is the AI in the platform, is it a generative sort of AI? Or is it the AI, is it manufactured by Chi-Square, or you are outsourcing to other AI applications? If maybe you can kindly give me a bit of insight on that. Thank you.
Yeah, our goal is not to, I mean, we use APIs from third-party sources, OpenAI and and Grok and many others. So depending on the performance in each use case, that we're using a particular API here today doesn't mean that when we use that same API, we evaluate it automatically based on the performance. The performances vary from time to time, and that's why any part where there's AI used, we tell you very clearly that there's AI used here, and you should, in fact, the default expectation is that it is wrong, right? That's the safest way to approach it, that by default, you should always assume that it is wrong, and it's your responsibility to very, very, very carefully review what it has produced. And that's why on everything that is remotely involving data, the platform does not use AI, from an analysis to management of references to anything. As far as it has data related to it, we don't use AI because of those risks, because AI can be inaccurate, so we need processes for those kind of high risk tasks. We need things that are 100% correct 100% of the time.
Thank you. Considering that this is a novel data analysis tool, is it globally accepted and approved? Would it be flagged for defending thesis or peer-reviewed journals?
Maybe if I know, flagged by who? There's no body that approves software for research. Again, those are things that it's your job as the researcher to do your due diligence. Obviously, before we put out a tool like this out, we have done our due diligence and validated. But those are decisions that you have to, decide what tool to use. I'm not a big advocate of tools, and you should. My recommendation is use whatever tool that works best for you. So if it's tool A, yeah, sure, absolutely stick to that. But so those decisions about whether to use a tool or not are not ones that those are your decisions as a researcher, and there's nobody else that makes those decisions for you. A tool is just a tool to get the results. So yeah, those decisions that you will have to make as the researcher.
Hi, Doc.
Thank you.
Great job on the presentation. How does your tool handle missing? Does it delete, or have you inbuilt system in how to handle the missing?
This is how you know you worked with somebody for so long that you can recognize their voice anywhere. Hi, Lazarus. See, you should not go around committing crimes where your voice will be used, because I would say that is Lazarus.
Okay.
Okay, so in terms of missing values, depends on the procedure, right? For regressions in general, all regressions perform listwise deletions, and so that is a default approach done. For certain approaches, for certain procedures, we allow you the option to group all missing values into one category, for example, called missing, so that those values are not thrown out of the window. We have intentionally refused to implement procedures like imputation because of their massive abuse. Most what they do is different from what people think they do. Procedures like multiple imputation require heroic assumptions, which are almost always never true. They require that data be missing at random, which is almost impossible to prove and almost always false, So for that reason, we have not implemented that because we think it does more harm than good, even if the researcher who may not know any better thinks that it's doing what they think it's doing. So yeah, but ultimately, we believe that those are some of the decisions that the research, because the researcher is the one that has the context for how the data are missing, right? They know that, oh, this particular data set is missing because this thing happened, right? You have that context. So we can't automate a detection of context. And so for that, it's extremely hard. But in the data collection part, the platform gives you the tools to prevent bad data, right? And that's why it's a continuum from data collection to analysis and writing. So in data collection, we have tools to make sure you collect good data. But when it comes to analysis, it's, since it's very context heavy, it's one of those things that we leave it to researchers. But one of the things we're planning to do in future releases is to allow for tools for IPW, inverse proportionality weighting, and for multiple imputation, despite our best judgment, but then provide a framework also, like a small AI tool that helps you evaluate whether that context that you have is appropriate for the use of those methods, so that people don't just blind. Because things like, if you give people a feature, they're going to use it. Even if it's doing horrible, horrible things to the data, right? Because they just feel, oh, just click a button and it does. And to them, it's like, oh, it has eliminated all my missing values. Now I have full data. It's like, no, you don't have full data. You have full troubles. But that's one of the things. But that requires a lot of deliberation and making sure that, we don't put people in harm's way. Because people will misuse those tools and they won't know any better for some of them. I hope that makes sense. Okay, any other questions? Have I been logged out again? Lungile?
Oh, sorry, I muted.
Okay.
All right, I think there are no more questions. If I missed any, please just repost now. Yeah.
Okay, thank you. I'm back again. Prof, I think I looked at the pricing for the platform. It's fair, but I don't know if I can say it's not too much student friendly. So, is there any package for students, if I may ask, please?
That question goes to Lungile.
Okay.
Yeah, we're working on it. We'll update our prices very soon.
Okay, thank you.
Thanks. If you buy the platform, do you have ongoing support?
Well, it depends on how ongoing your ongoing support is. Well, that's true. Is that not a fair answer to a fair question?
What I mean by ongoing support is that
I'm just being silly here.
I understand the ongoing support can be endless,
Exactly.
but not that kind of endless support.
Okay.
I know this is a new platform, and you need to learn
Yes.
as you use it.
Very
Maybe you
true.
get stuck somewhere, you want to do something, you don't know what to do, and then you need maybe a community to ask, oh, what if I want to do this? Where
Yes.
do I go? And all that. That's the
Those are
kind
fair
of
questions. And first of all, I was just being very silly. So yes, there's ongoing support of that kind.
not the endless one.
Not the
Not the
endless one. Like we won't exactly move into your house.
Understand.
Yeah, but we'll provide that kind of support. Yeah.
Can this platform give leverage in modifying a particular referencing style? For example, modifying APA to suit a particular journal using a modified version.
Yes.
Okay. Is the platform useful for qualitative research from the beginning to end?
Well, it's not designed for qualitative research, so it can't solve all problems in the world. But I mean, it depends on how you're using. Obviously you can use the word editor for some part of your work, but you have to be creative. But it's not designed as a qualitative platform. It's designed as a quantitative platform or a platform for quantitative research.
Thank you. I think that's all.
Okay.
What do you have in mind? Do you have in the future something
Yes.
qualitative for those of us who do qualitative research?
Yeah, actually, we have a platform being built right now called qualitate.ai.
All right.
But unlike the analysis engine here, which is highly like 100% rules-based algorithms or rules, not AI, that one is purely AI, obviously, because we're dealing with text. So that's a distinction. So when we say that our analysis engines don't involve AI, that would be an exception to that rule, because that kind of analysis is inherently, in the AI domain.
Thank you. That's all.
Okay.
That's all. No more questions.
All right, that's good. All righty. Thanks, everyone. And so we hope you enjoyed the condensed Harvard sessions. The Harvard sessions were obviously all day, so it's definitely a great relief just talking for a much shorter period of time. And we do hope you find the platform useful. All right. We'll see you next. We'll have a hand up. Let me find ways of exiting the stage while that person asks a question. I don't know why I can't find that button. Like when I minimize the stuff, then it just disappears. I am like, geez. Oh my goodness.
Well, Ojore would like to ask you a question before you go.
Okay.
Yeah, Prof. This is awesome. It's a no-brainer. I just wanted to find out if there is a provision for. I know this is already concluded, but for those who are before subscription, do you have any trial period for individuals to try some of these things you have taught and then make a decision on whether to go on or not?
Yeah, I mean, there's a free version of a platform of each of the tools. You can upload your data set, for example, and do quite a bit of things with it. Of course, there are some processes that you may not be allowed to perform, but that they will provide sufficient depth and breadth of operations that should give you a flair for what you're going to get. I hope that answers the question.
Yeah, that's fine. Thank you.
Very awesome. Thanks. Yeah. Longile, I think I'll just have to start switching on my computer. I genuinely don't know where. This is
But
crazy.
we like to have you here.
Well,
You don't have to go. We will just end the session at some point.
Oh, no, that's a really bad idea. Well, I just will switch off my internet, I guess. That's a shortcut. All right, thanks everyone. Bye.
Bye.
Bye-bye, Prof.
Bye.
Thank you very much. Bye-bye.
Thank you.
Thank you. Bye bye.
Thank you, Prof. Well done.
Thanks so much,
Very
Prof.
insightful.
We
Thank you.
appreciate your
Bye.
presentations.
Thank you.
God bless you. Bye-bye.
Thanks a lot. God bless you, Prof. We are much grateful.
Bye.